it's me, Teacher Jeanne. In this lesson, you will learn about factoring perfect square trinomials, or PST. After going through this lesson, you are expected to factor the perfect square trinomials. In our previous lesson, I already discussed the list of perfect squares and the square root of perfect squares. So again, you need to know, master, and memorize all of them because they are very essential to many aspects or in our future lessons in math. So here, listed the perfect squares and the square roots given the variables. So let's have a squared. So 2 is the exponent, and if the exponent are 2, 4, 6, 8, 10 or multiples of 2 or even numbers, they are considered perfect squares. Now given square root of a squared, from the word square, the index is 2 and it is understood and no need to write it. A is the radicand and we have the symbol for the radical sign. Square root of a squared is equal to a to the power of 2 divided by 2. So we have a to the first power, or simply a. So therefore, square root of a squared is equal to a. Next, given square root of m to the sixth, and that is equal to m to the sixth divided by 2. So 6 is the exponent divided by the index 2. Then simplify, we get m cubed. So therefore, the square root of m to the sixth is equal to m cubed. Now, think about this. Given the quantity of x plus y times the quantity of x plus y, as you can see, we have the same first term x and we have the same second term y, and the operation are both plus. So they are considered identical binomial and can be written as the quantity of x plus y squared. Same as given the quantity of x minus y times the quantity of x minus y. So as you can see, we have the same first term x and we have the same second term y. The operation are both minus. So they are considered identical binomial and can be written as the quantity of x minus y squared. So the first given are considered the expanded form, which is equal to its exponential form. Here, we need to recall the special product given the square of binomial, or SOB. So let's have the quantity of x plus y squared. To get the product, we're going to square the first term, x squared, and the last term, y squared. They are both positive. And for the middle term, that is 2 times or twice the product of the first and the last term of the binomial. And if the operation of the binomial is plus, the middle term is also plus. So the quantity of x plus y squared is equal to x squared plus 2xy plus y squared. Next, we have the quantity of x minus y squared. And to get the product, we square the first term and the last term. So we have x squared and y squared. And they are both positive. And for the middle term, again, that is 2 times or twice the product of the first and the last term of the binomial. And if the operation of the binomial is minus, the middle term is also minus. So the quantity of x minus y squared is equal to x squared minus 2xy plus y squared. And these are what we call the perfect square trinomial. So as you can see, it consists of 3 terms, also known as PST. Now what's new? Let's proceed on our lesson, which is factoring perfect square trinomial. Now as I have said, factoring is the reverse of multiplication or getting the product. So here, given the perfect square trinomial, or PST, the factor is the square of a binomial, or SOB. So let's have the given x squared plus 2xy plus y squared. To get the factor, we write it in the square of a binomial. Then we get the square root of the first term, x squared, we have x. Then the square root of the last term, y squared, we get y. And if the middle term of the trinomial is plus, the operation of the binomial is also plus. So we have the quantity of x plus y squared. Next, given x squared minus 2xy plus y squared, to get the factor, we write it in the square of a binomial. So we get the square root of the first term, x squared, we have x. We get the square root of the last term, y squared, we have y. Then, if the middle term is minus, the binomial is also minus. So we have the quantity of x minus y squared. So the quantity of x plus y squared and the quantity of x minus y squared are the factored form. A trinomial is a perfect square if it satisfies the two conditions. First, the first and the last terms are perfect squares and both are positive. Second, the middle term is twice the product of the values that were squared. Now, for you to understand, let's have the activity. Determine whether these are perfect square trinomials. If yes, factor the trinomial. So let's have number 1, x squared minus 6x plus 9. Now let's see if the given satisfies the two conditions. First, the first and the last terms are perfect squares and both are positive. X squared and 9 are perfect squares and they are both positive. So that is yes. So square root of x squared is x and square root of 9 is 3. Next, the middle term is twice the product of the values that were squared. So we have negative 6x. So that is equal to negative 2 times the first term x times the last term 3. So we have negative 6x. So that is yes. So now we can write it in the square of a binomial. So the first term is x and the second term is 3. So x squared minus 6x plus 9, if the middle term is minus, the binomial factor is also minus. So we have the quantity of x minus 3 squared, which is the square of a binomial or SOB. Now to check if your factor is correct, let's have the quantity of x minus 3 squared. Let's use the special product. We square the first term, we have x squared. If the binomial is minus, the middle term is also minus. Twice the product of the first term, x, times the second term, 3. Then square the second term, we have 3 squared. So simplify, we have x times x squared, negative 2 times 3 times x, negative 6x. 3 times 3, we have 9. So we have x squared minus 6x plus 9, which is the perfect square trinomial or PST. So you got it correct. Another way is using FOIL method. So write it in the expanded form. We have the quantity of x minus 3 times the quantity of x minus 3. So multiply the first terms, we have x times x. Multiply the outer terms, we have x times negative 3. Multiply the inner terms, we have x times negative 3. And multiply the last terms, we have negative 3 times negative 3. X times x equals x squared. X times negative 3, we have negative 3x. X times negative 3, again we have negative 3x. Negative 3 times negative 3, we have positive 9. Combine similar terms. As you can see, we have negative 3x plus negative 3x, we have negative 6x. So the product is x squared minus 6x plus 9. And we got the same answer. Example 2 is 4m squared plus 24m plus 36. Now let's see if the given satisfies the two conditions. First, the first and the last terms are perfect square and both are positive. So we have 4m squared is a perfect square, 36 is also a perfect square, and they are both positive. So that is yes. So the square root of 4m squared is 2m, and the square root of 36 is 6. Next, the middle term is twice the product of the values that were squared. So we have 24m is equal to, so if the middle is plus, we have plus 2 times the first term 2m times the last term 6. So we have 24m, and that is yes. Now we can write the factor in the square of binomial. So the first term is 2m and the second term is 6. So if the middle term is plus, the binomial factor is also plus. So the factored form is the quantity of 2m plus 6 squared, which is the square of binomial or SOB. Now to check if your factor is correct, we use the special product given the square of a binomial. So first, square the first term, we have the quantity of 2m squared. If the binomial is plus, the middle term is also plus. Twice or 2 times the product of the first term 2m times the second term 6. Then for the last term, square the second term, we have 6 squared. So simplify, 2m times 2m, we have 4m squared. Positive 2 times 2, we have 4 times 6, we have 24m. Plus 6 times 6, we have 36. So the product is 4m squared plus 24m plus 36, which is the perfect square trinomial or PST. So you got it correct. Next, we can use the FOIL method. So write it in the expanded form. We have the quantity of 2m plus 6 times the quantity of 2m plus 6. So multiply the first terms, we have 2m times the quantity of 2m. Multiply the outer terms, we have 2m times 6. Multiply the inner terms, we have 2m times 6. And multiply the last terms, we have 6 times 6. Then simplify, 2m times the quantity of 2m, we have 4m squared. Next, we have 2m times 6, we have 12m. 2m times 6, same, we have 12m. 6 times 6, we have 36. Then combine similar terms, 12m plus 12m, and that is 24m. So the product is 4m squared plus 24m plus 36. As you can see, in any method, we come up the same answer. For example, number 3, given x to the 6th plus 8x cubed plus 64. Let's see if the given satisfies the two conditions. First, the first and the last terms are perfect squares and both are positive. So we have x to the 6th and 64 are perfect squares and both are positive. So that is yes. So the square root of x to the 6th is x cubed and the square root of 64 is 8. Next, we have the second condition. The middle term is twice the product of the values that were squared. So the middle term is positive 8x cubed. So we have positive 2 times the first term x cubed times the last term 8. So we have 16x cubed. So as you noticed, since the middle term is 8x cubed instead of 16x cubed, it does not satisfy the condition. Therefore, the given is not a perfect square trinomial. The fourth example is x squared plus 10x minus 25. Now let's see if the given satisfies the two conditions. First, the first and the last terms are perfect squares and both are positive. Now as you can see, the last term is not a positive. So it does not satisfy the condition. Therefore, the given is not a perfect square trinomial. Now let's do more. Factor each completely. The first perfect square trinomial is 4a to the 4th plus 36a squared plus 81. And the factor is written as the square of a binomial. Now for the first term, we get the square root of 4a to the 4th, which is 2a squared. Now if the middle term is plus, the binomial factor is also plus. Then get the square root of 81, we have 9. So the square of binomial is the quantity of 2a squared plus 9 squared. Next, we have number 2, x minus 24xy plus 144y squared. Now the factor is written as the square of a binomial. Now for the first term, we get the square root of x squared. We have x. Then, if the middle term is minus, the binomial factor is also minus. Then, get the square root of the last term, 144y squared, we have 12y. So, the factored form is the quantity of x minus 12y squared. Next, number 3, we have 16x to the 4th plus 49y to the 6th plus 56x squared y cubed. Now, the first term is a perfect square, the second term is perfect square, and the last term is not. Here, we rearrange so that we have 16x to the 4th plus 56x squared y cubed plus 49y to the 6th. So the factor is written as the square of a binomial. Now for the first term, we get the square root of 16x to the 4th, so we have 4x squared. And if the middle term is plus, the binomial factor is also plus. Then we get the square root of the last term, 49y to the 6th, we have 7y cubed. So the factored form is the quantity for x squared plus 7y cubed to the second power. Next, we have the fourth, 2x cubed minus 28x squared plus 98x. So as you can see, 2x cubed is not a perfect square, and 98 is not also a perfect square. But here, we can factor out the greatest common monomial factor. Now, for the coefficients, we have the greatest common factor 2. And for the variable x, we have x to the first power, or x. So the greatest common monomial factor is 2x. Then, we're going to divide each term with the greatest common monomial factor. So we have the remaining x squared on the first term. So negative 28 divided by 2, we have negative 14. Then x squared divided by x, we have x. 98 divided by 2, we have 49. Cancelled x equal to 1. Then, we're going to write the greatest common monomial factor times the remaining factor, which is the square of a binomial. So we're going to get the square root of x squared. We have x. Then, if the middle term is minus, the binomial factor is also minus. Then, the square root of 49 is 7. So, the factor is 2x times the quantity of x minus 7 squared. Now, it's your turn to eat yourself. Let's see if you learned something on this video. Factor each completely. First, x to the 12 plus 10x to the 6th y squared plus 25y to the 4th. Number 2, 9a to the 6th plus 60a cubed b to the 4th plus 100b to the 8th. Number 3, 3m to the 4th minus 6m cubed plus 3m squared. Don't forget to comment down below your answer. Happy learning! Thanks for watching. Please like and share. And don't forget to subscribe on my channel and click the bell button so that you will be notified whenever I'm going to upload a new one. Maraming salamat!